For this lesson, you will self-mark and do corrections for your theory workbook, section 7.1 and 7.2. Page 96. A. The volume of 20 centimeter cube of beer and 20 centimeter of tomato juice are mixed and the total volume is less than 40. Explain. In the previous SLS lesson, you watched the demonstration and the reason is due to space between particles. B. A balloon can be easily compressed. Why? This is a diagram of a gas at low pressure. At high pressure, the gas can be easily compressed. Why? Again, it's due to the large spaces between the gas particles. C. We can smell the scent of flowers from a distance. Why? The particles of matter can move freely or randomly. D. When sugar dissolves in water, the volume of water hardly changes, even though sugar is added. This is similar to question A. There are spaces between particles of matter, and the water molecules and sugar molecules are able to fit into spaces between each other, making the total volume less than you would have expected. Question 3. It shows 3 gas jars set up differently. In setup A, the brown gas is at the top. Setup B is laid horizontally, and the brown gas is on the right-hand side. Setup C, the brown gas is at the bottom jar. This experiment investigates diffusion of gas, which is also simply the movement of gas particles. If you understand how gas particles behave, they are able to move freely and randomly to occupy any space available. So, the results in all 3 experiments will be the same, and it shows the presence of the brown gas in both gas jars. Air is not visible to the naked eye, but it will also be able to diffuse upwards in the case of A, diffuse to the right in the case of B, and C, diffuse downwards, because gas particles are able to diffuse in all directions. So the results show particles of gas can move about freely or randomly in all directions to fill up any space available. C. Which experiment shows that the movement does not depend on gravity? In setup B, the brown gas particles and the air particles are moving horizontally, so it is not affected by gravity. Question 4. Fill in the blanks. Matter is made up of small particles which are invisible even under a powerful microscope. There are spaces between the particles. The spaces between gas particles are the largest. These particles of matter are continually moving. Question 5. Models can be used to make predictions. If you break a bottle, the gas particles will escape to the surrounding. So the distance between the particles would increase, and the gas would also mix with air particles in the surrounding. Question 6. How do we know the particulate model is a good representation of what matter is made of? This model is good and still stands because it explains many observations of solids, liquids, and gases, especially because it also has made predictions that turned out to be correct. Next, we move on to section 7.2. Please do your corrections in green. We are unable to see atoms or particles with our naked eye, so we use models to explain the behavior of solids, liquids, and gases. Question A. Give 2 reasons why models are useful in science. As mentioned earlier, it can represent something that is too small to be seen, or number 2, is too large or complicated to be studied easily. For example, the solar system. Question B. Which represents a solid, a liquid, and a gas? This one here is quite closely packed. Liquid. Far apart, gas. Very closely packed, solid. Now, we are going to fill in the blanks to describe the arrangement, the distance between particles, and the movement of particles in solid, liquid, and gas. Solid particles are arranged in a regular pattern or an orderly pattern. Liquid particles have no fixed pattern or they are disorderly. Gas particles are also disorderly or have no fixed pattern. Distance between particles. Solid particles are packed closely together. Liquid particles are packed less closely together compared to solids. Gas particles are far apart. Movement of particles. Solid particles vibrate in fixed position. Liquid particles slide across each other over short distances. Gas particles move freely in all directions. You may also use the word randomly. Complete the table using yes/no to describe the properties of solid, liquids, and gases. Solids have definite shape. Solids also have definite volume. However, solids cannot be compressed because the particles are too closely packed and there is little space in between particles. Liquids don't have a definite shape. They follow the shape of the container. Liquids have a definite volume. Liquids cannot be compressed because the particles are quite closely packed. Gas particles don't have definite shape or volume, and gas particles can be compressed. Complete the diagram to show the gas particles after compression. What would happen if you push the plunger of the gas syringe? Will the particles get smaller in size? Or would the space in between particles become smaller? The answer is the particles remain the same size, but the space between particles becomes smaller. Question B. Gases are easier to compress than solids or liquids. We consider solids and liquids to not be able to be compressed. Gases can be compressed. Why? The spaces between gas particles are much greater than the spaces between the particles in liquid and solid. This allows the particles to move closer when they are being compressed. Question 4. Use the particulate model of matter to explain the following. When you see this statement in a question, use the particulate model of matter. Your answer needs to make reference to the word particles. Question A. A liquid can flow and take the shape of its container. This is because the particles in a liquid are not in fixed position and liquid particles are able to slide past one another. Question 4b. The densities of gases are less than the densities of solids and liquids. Recall density is mass per unit volume, and it tells how packed particles are. In an object. So how do you explain that in terms of particles? The particles of gases are far apart than in those of solids and liquids. So gases have fewer particles per unit volume as compared to solids and liquids. I will draw this to illustrate to you. This is a solid. This is a liquid, and this is a gas. All three have the same volume. But in this solid, you can see 9 particles. In liquid, you can see 5 particles. And for the gas, 3 particles. Because the gases have fewer particles in the same volume, it is considered to be the least dense. Question 5a shows a solid expanding. 5b, a gas expanding. Take note, the size of the particles remains the same. The change is only in the space between the particles. The same happens when a gas expands. The space between the gas particles increases. Question 6. Draw the diagram to show what happens when salt dissolves in water to form a solution. Salt is a solid. Water, a liquid. Notice I drew 12 particles for salt and 10 particles for water. When you mix them together to form a salt solution, I should get back 22 particles. Why? Question B. Particles cannot be made, created, or lost. When the air in a hot air balloon is heated, the balloon rises. Complete the paragraph below to explain why a hot air balloon rises. A. When air is heated, the spaces between the particles increase. As a result, the density of the hot air is less than that of the cold air. Therefore, the hot air together with the balloon rises. What change, if any, happens to the total number of particles? As with the previous question, there should be no change because atoms cannot be created or destroyed. Only the speed and spaces in between particles will increase when heated. The particles gain heat and they would move faster. This is the end of section 7.2. You are to complete worksheet 7.1. Take a photo and send it to your respective science teacher.